Welcome viewers, welcome back to my channel. I'm Dr. DORCAS NGIGI. We have been moving together. This is the third lesson. In the first lesson we looked at upthrust. In the second lesson we looked at the apparent loss in weight. So in this lesson we are going to look at sinking. We're going to look at sinking. And the next lesson, we shall look at flotation. Okay? So sinking, what is to sink? To sink is that act of an object going inside a fluid. Sinking is that act of an object going inside a fluid. Well, that is according to me. Now, why do bodies sink? That's what we are going to look at. Why does one body sink while the another body floats? So in sinking, let's go back to what we know. We said a body in a fluid, and this time a fluid, we say that fluid is a liquid or a gas, has two forces acting on it. Now we are talking about a body that is stationary, not moving, because now when it starts moving, now there's the frictional force, the viscosity, which comes in. Now we are assuming our body is static inside a fluid, it's not moving. Now if a body is not moving, but is totally immersed in a fluid, there are two forces acting on that object. There is the weight of the object, the weight W, which we said equals to mass times gravity, where m is the mass of the object. And then there is the upthrust, which is directed upwards. Okay? Now, in the first lesson, we looked at the source of this upthrust, which we said is the pressure difference between the two ends of an object. Now, we are not going to go to that. If you want a refresher on that, go back to my first video. Now, we said if the weight of that object is greater than the upthrust on the object, then from Newton's second law, the resultant force will be W minus U, and that resultant force will be directed downwards. Okay? If the weight of the object, which is directed downwards, is greater than the upthrust on that object, then the resultant force will be directed downwards. Remember, forces are vector quantities, so when they're in the opposite direction, we subtract them. If they're in the same direction, then we add them up. So the upthrust, the resultant force W minus U, which is our R, is directed downwards. Now from Newton's second law, force, which this time is our resultant force, is our force, the actual force acting on the object, is a product of mass times acceleration. Mass times acceleration. So the body should go down with an acceleration. Okay? The body should go down with an acceleration A. Now this F, as we have said, is a resultant force. Weight mg minus upthrust. Whatever we get is the resultant force R, is the actual force that is acting on the object which is inside the fluid, and so it should go down with an acceleration A. Okay? Now, that going down now brings about sinking. So therefore, a body will only sink in a fluid if its weight exceeds the upthrust on it by that fluid. A body will only sink if its weight exceeds the upthrust on it due to that fluid. That is sinking. Okay? So, if it that's why you see a body might sink even if it's very small. Another body might not sink even though it's very big. Because remember, upthrust can be manipulated. In the last lesson we said that upthrust is equal to the weight of the fluid that is displaced. But we also said that this weight of the fluid displaced is dependent on the volume of the object inside the fluid, because the volume of the object and the volume of the fluid displaced, the two are equal, especially if the object has sunk, meaning it is inside the fluid. So if then you will have increased the upthrust. Now, how can we increase the volume? Maybe by thermal expansion. You can hit the object and it will occupy a bigger volume than before. Then it will occupy a larger volume of the fluid, so a larger upthrust. So what we're saying here is upthrust can be manipulated if the volume of the object can be manipulated. But the weight of the object, that one does not change. That is constant. Okay? So in the last lesson, we calculated the upthrust on a ball that had a radius of 7 centimeters. We took it to be a sphere of 7 centimeter radius. Okay? So being a sphere, volume of a sphere is volume of the sphere equals to volume of water displaced. So meaning that the volume of water displaced equals to 4/3 times pi 22/7 times 7 cubed centimeters cubed. Okay, so that gives the volume of the object. We also say now density of water, which is 1,000 fresh water, assuming we are using fresh water, is 1,000 kilograms per cubic meter. So what I can do, I can divide this by 1,000. That way I'll convert my volume now from centimeters cubed to multiplied by a million, not 1,000. Remember, 1 meter is 100 centimeters. So 1 cubic meter is 100 centimeter times 100 centimeter times 100 centimeters. So it's 1,000,000 centimeters cubed. Don't get lost. So I can say that instead of this putting centimeters cubed, now I can put meters cubed. Okay? So pi r cubed, 4/3 pi r cubed, that's the volume, times density of water, which is 1,000 kilogram per cubic meter. Okay? Now that gives us mass. So this now gives us, now if I take, let me not, I don't want you to get confused. So mass of water displaced becomes, let's say this cancels and this leaves 2. So it's 4/3 times 22/7 times 49 meters cubed divided by a million times 1,000 kilograms per cubic meter. Now that is density. Okay? Density of fresh water. So that cancels. 3r minus 3, that is 0. Every whole number, every number raised to power 1, raised to power 0 is 1. Okay? So that one is extinct. So whatever we get is mass of displaced water, which is in kilogram. Now the weight of that displaced water, which is also equal to upthrust, remember, don't forget, will be equal to what now? Will be equal to this mass times gravity. So we have 4/3 times 22/7 times 49 over, now let's remove this, 1, 2, 3, 1, 2, 3. So divide by 1,000 kilograms times gravity, which is 10 newtons per kilogram. Okay? Again, as you can see, there's kilogram and there's per kilogram, so they cancel. And then we have 3 zeros, 1, 2, 3, 1, 2, 3. So we get the weight, which is our upthrust on our ball, as 4/3 times 22/7 times 49 newtons. That is our upthrust. Now, whether this ball of ours is going to sink, that will depend on its weight. Okay? That will depend on its weight. Now, if its weight is greater than this upthrust, then we expect the ball to sink. So it will move down the fluid with an acceleration A until it hits the bottom of that fluid, of that water. Remember, we were using water in the last lesson. So it will move down with an acceleration until it hits the bottom of that given container which is holding our water. So upthrust on an object is that, so sinking will only happen if the weight of the object is greater than the upthrust on that object. Now, what if the weight and the upthrust are equal? Or the upthrust is greater than the weight, then what would happen? Now, if the weight is equal to upthrust, then the object will float. If the weight is equal to upthrust, then the object will float. Let's say that the weight of the object if weight is greater than 4/3 times 22/7 times 49 newtons, then the body sinks. Okay, but if weight of our ball is equal to 4/3 times 22/7 times 49 newtons, then the body, which is this time is our ball, floats. Okay. Now, I hope you have understood sinking, and you have also understood that any body that is placed in a fluid, it experiences an upward force by that fluid, and that upward force is called upthrust. Number two, the source of that upthrust is the pressure difference between the two ends of that object, which is in the fluid. Number three, if we are talking about sinking, where the object is totally inside the fluid, then the volume of the object inside the fluid and the volume of the fluid that is displaced by that object, the two volumes are equal. And the upthrust is equal to the weight of that fluid that is displaced by that object. And today we have seen that for an object to sink, then its weight must be greater than the upthrust on that object. Now, in our next lesson, we shall look at flotation. Remember, we have said for a body to float, its weight must be equal to the upthrust on it by the fluid. So when the weight and the upthrust are equal, then the body floats on a fluid. So in our next lesson, we are going to look at flotation. Let's stop at that point. I hope to see you in my next video. Don't forget to like and subscribe. Thank you very much.